Hello guys, welcome back to the extension of our first video with EROS about the lighting in video games. This is, as we promised, like a sort of Q&A, not really Q&A, but we received a lot of feedbacks and questions in my Discord server relative to the video we did, which was an intro to physically based lighting for video games, and alongside that, the practical part was about cinematics. So we went through them, and Eros already answered directly on the server to the people that asked the questions. But as we said, we sort of gathered the most common topics that were coming out, and we identified some main topics where that we want to furtherly discuss. We won't go as deeply as in a full episode of this series, let's say, but it's a good extension if you followed our previous video. Initially, we identified, let's say, 6 topics, but today we will go through 3 of them, mainly because 2 of them will be discussed in a much deeper way in a later episode, so it's not worth to just mention them and not really dive into them like properly. So just to give you an example, talking about color profile and gamma, we won't do it now because it's about a bigger discussion that we'll do in another episode. And also why it's not enough to just have physically based lighting in your project, like just to not stick with the physically based lighting to have a proper result, but you also need to stick to the physically based rendering, the PBL and PBR things working together. So having the correct values in your textures, all these things. We don't talk about this today. What we will instead talk about is a quick overview about the lighting for VR and how relates with the current tech that we work with normally in video games. What are the limitations of it and why we still have to work differently, let's say. We will go through a quick setup of an overcast condition and nighttime condition. We will talk about emissive for physically based lighting, and that's it really. Then we will give you some anticipation on what we will talk about in the next episode. So let's go through these topics and let's start from VR. So Eros, welcome back.
Thank you.
What do you have to say about it?
So a bunch of things, but in a way, it's likely I worked with VR in a real engine in the past, not directly a lot with Lumen, but I worked with baked lighting with VR and also production of assets and lighting as well. So in the question, it was likely how can I approach the lighting for a VR field, or which one is the technique that I have to use? Can I implement Lumen? Can I implement baked lighting? So the answers at the moment are quite strict. For example, in terms of technology, the one that is much more reliable for VR is baking. So we have baking lighting that is really reliable, it works really well, and is really light in terms of performances. And we have to take in mind that whenever we work in VR, we want the 90 FPS experience in order to not make people like puke while they are experiencing the VR with the headset. So the baked lighting has been updated in a real engine. So we have the GPU light mass that is increasing the quality in some ways and is reducing instead the time for baking the scenes. So it's really, really powerful. But for the baked lighting, there are other restrictions that are, for example, UVs, managing of memory, because whenever we use a GPU light mask, we are a little bit more enclosed to the amount of VRAM that we can actually dedicate for the baking. Instead, with the CPU one, that I think also you, Gianpietro, are familiar with, we had the RAM as our limit per se on the amount of objects that you could likely bake into our scenes, and it was much slower. It was likely a brute force type of rendering, so it was not using denoiser of the as the GPU one, and it was not using that much of ray tracing. It was more of a brute force path tracing, but it had the possibility to encompass a lot of more information in terms of memory. So I would say we are not going through those information since it will take a lot of time, because the baking is a topic by itself. So I would say you can write in the comments if you are really interested into that and if you want to see a workflow. In that case, it's probably not. We are not gonna speak about it here in this channel since it's for archivists more as a topic. It's not really dedicated to video game. Uh, for this series, we are not probably speaking about it. But yeah, let us know in the comments if you want to hear more about it.
Yeah.
And one other, yeah, sorry, go ahead.
No, no, I was saying like I can do the technical artist and say just if you want to have like a sort of mental image about what it means working for a VR, like in a proper way, think about the fact that you have two screens, not one. So you're rendering two images every frame. Uh, the resolution needed is higher than what you can get away with a normal screen, because the same pixels you have on the screen are actually covering the entire field of view that you have with your eyes, so their relative size is bigger. So let's say that if you can get away with full HD with a normal screen, 4K is barely enough to get enough resolution for VR. I mean, that's what we have now in the visors, but it's not enough. Then, as Eros has said, like if you don't want to throw up while you use it, you have to go at 90 FPS. And 90 FPS is like saying 30 FPS for the video games, like it's the low bar. So
Should be 120 actually, right?
yeah, exactly.
The right amount should be
Yeah.
60.
Yeah. So that said, you can imagine like if it's hard to render whatever you're trying to render at 16 milliseconds, half the time and double the resolution, and that's what you get.
It looks
as-
beautiful.
That's
That's
it. And not only that, like for example, backlit lighting from a tech art point of view also has other implications that at the moment we are not dealing anymore, because we tend to use lumen, everything is dynamic mostly and stuff like that. But since now we are all used to just take the megascan stuff, billions of polygons, and cram it in the scene, and we all have memory issues and stuff, keep in mind that being forced to have one more UV channel per mesh means like not doubling, but increasing a lot the memory footprint of each asset, because the UVs like need to be saved in memory. So having one more UV channel means having a two-dimensional copy of every vertex that is in the mesh. So if we are already strict in memory with normal video games, we are even more strict in VR if we use baked lighting, of course. And of course, you also have the baked textures. So even though at runtime is cheaper, the baked lighting, you sacrifice dynamism for quickness, let's say, like for the baked stuff, it's static. But also means that you're occupying much more memory, because the data of the light needs to be saved and taken from memory each frame to be displayed. So yeah, it's very tricky. I mean, to be as a technical artist, it would be like a great challenge to work on a VR project, but doesn't come from free. Like a lot of issues.
Yeah. No, yeah, it's really complex. So it has so many more implication changes of workflow. Like for example, in a VR field, it's better to add bevels to assets instead of creating a normal map because of the memory restrictions, and also how the lighting interact with that, with the amount of light maps that you create. Because they are like, if your scene is really complex, you will have a lot of light maps. And if your texel density of the light maps is really big, the resolution based on the texel density, it needs to create more atlases. So there is a lot of balancing
Yeah.
in between those information. But yeah,
Yeah.
it's
Another
really
terrible
interesting.
thing that I just thought now is the virtual shadow map. If you want to use the virtual shadow
Oh,
map, good
yeah.
luck because you need two. No, you need one actually, but you need to fetch probably different pages per eye, maybe. I don't know. Also, Nanite, who knows how it works if you have to render two frames at the same
Double.
time. Yeah,
Yeah.
if you end up using Nanite. I mean, it's really unexplored grounds at the moment, so
Yeah, yeah. No, yeah. On the lighting side, I can surely tell that baked lighting it's more likely the way. If your scene is not that complex, then you can also use lumen, but always take into account the amount of performances that it takes out from you. So that's really important, and I think it's really dependent per project basis. But we know that lumen is heavy, so
yep,
take it in mind. Yeah.
yep. All right, that was just to quickly talk about it. Then, if there is a lot of interest, the thing is we don't have a visor ourselves, so it's not that we can like properly test what we would say. So it would be a bit more up in the air, and it's not really worth it. Yeah, just to carry on, let's do some funny practical stuff, and let's talk about overcast and nighttime lighting with BBL.
Yep.
BBL.
Yes. So here you can see we are in our famous electric dream scene, as always. It's our caveat for all the tests that we do so far. And in here we are going to test a little bit the production of a overcast uh, overcast time of day, so weather, sorry. So an overcast weather, um, and see which one are likely the restriction or the best ways to have that kind of effect in our scene and that type of weather. So here we have the scene set up with a physical based lighting as we already know. So it's always the same type of setup with everything we have already done in the previous video. So if you need more info or you don't know precisely what we have talked about, please take a look at the video that we have already recorded. So I think it will be added to the description and also here as a hint.
Yep.
But likely here now we are going to focus on the overcast, since the biggest issue per se with it is that people says it's too flat. You know, that's the first thing that everyone says about an overcast type of condition, and that's true. I mean, in real life, it's flatter than having contrast with the light, with the direct sun. So, because of that, we have to understand which information we are getting from the screen. So in order to go to the overcast weather, we need the volumetric cloud. Okay, the volumetric cloud actor. I'm using the one from the Electric Dream, so they have already a shader with the cloud system, and I will enable it. And what I have done for now for us, I covered the whole sky with the clouds, but now you can see this noise is because of the layer height that is very low. And I used it to just show how much it actually counts the layer height and how much it counts the thickness of the clouds in order to occlude the sun. Because the thing is, we are not going to touch any light values at all, either exposure or either direct sun intensity. Because the typical thing that everyone does is taking the sun, reducing the intensity based on, for example, the tab that we showed in the first video with the physical base light units that says how many lux are on the ground whenever we are in a overcast day, or which one is the right EV that we have to expose in order to have the right exposure for the overcast weather. But in this case, because we have dynamic information moving along while we play, in this case, like in a game, we cannot like change those information, or if we do it, we are gonna take like so many more issues because it just changes the exposure, it changes the way we expose our scene, it changes the way lights reacts because of the sun having lower values. So because of that, we just use a system that we have already in Unreal that are the cloud shadows. You're gonna see it if I increase the occlusion, right, from the clouds to the sun. Now you can see that we are getting a lower amount of sun. We still have some hints of it because it's not fully covered. So if I go here in the material and I change the mask bias to cover it even more, now you can see that we are fully covered. So you can see that it's fully occluded, and what is giving us the actual lighting is the skylight. Okay, so it's the skylight that is capturing the sky atmosphere that we have right now, that are basically the clouds that are scattering the sun, right? And the actual sun that is reacting to the clouds. So based on the sun, we know which one will be the information of light. And I think, Gianpietro, we can mention this issue right here that is regarding the water that is not getting the cloud shadow, right? That's why it's slightly
Is this
brighter.
the single layer water?
I think so, yeah.
Yeah. By the way, I was gonna say I can confirm you guys that this result is correct because it makes me feel home. Like that's how I live. That's my life in here in the UK. Since since I moved here, that's what I see. Like that's I forgot that things have shadows under there. Um
Yeah, you can use your PTSD of cloudy days.
yes. So about the water,
The water, yeah.
it was like very painful when it happened the first time, but then the fix is quite easy. So basically, this is single layer water, the new water pass that Epic added. I don't remember how many versions ago, to be honest. Um, which basically is like a translucent pass but specific to water. It's like a stage of rendering separated from everything else. And you have to tell the engine that you want that this layer samples the shadows from the clouds, and that thing is in the project settings to activate.
Okay, yeah, no, yeah. It's good to know because I mean, people starts to get these kind of reflections, and then they don't know where they are coming from and why things looks brighter than anything else. So yeah, um, so yeah, continuing on the topic of the cloudy that we are getting right now, as you can see, the areas that before, now we can see that before had like much more light, now are darker. Okay. In fact, I can actually also play the scene. I have a basic locomotion system to just show up a gameplay. So yeah, here you can see the system. So I can navigate with a character, and we can see which one will be the visibility of the player. I go full screen. You can actually see it. So as you can see, we still see information because we are using all the topics that we spoke about in the last video. So we are using the RAI TVs, we are using the local exposure that is helping us to compensate. So the local exposure, of course, will be mentioned more in the future videos, more in depth. But you can see that the visibility for the player is there. So we can see fully the environment without any problem, like that. And we can visualize it. But then, let's say we go inside here, as we were before, and we get this really dark information. So those ones in a PBL uh, field should be taken as dark areas. Why is it dark? It's dark because it's enclosed and there is no skylighting leaking enough in order to illuminate it. So we all know that the skylighting system of Unreal Engine with Lumen is not perfect like a path tracing is. Okay, the multi bounces, how much the skylight leaks, and so on. So unfortunately, we cannot uh, say that that's the perfect amount of skylight that we will get from a cloudy day. But still, if, because we have to be flexible as the system should be as well, we have to understand which one are the ways that we have in order to accomplish the image that we want. So one thing that now it will reconnect to the nighttime is to have a range on the post-process exposure. So I'm gonna mentioning it, but then it will be mentioned more in depth into another video. Why of the choices that I'm making and that I will make right now. So what I will do will be to have a minimum AV of 1, okay, but with the speed of adaptation that is really low. So right now it should be 1 minute, I think, if I remember well, like the 0 1 should be 1 minute of time in order to give to the exposure system to go to the required EV that we can visualize here in the visualize HDR eye adaptation. So we can see that is slowly moving towards the median EV that is needed in order to expose correctly the scene. But why am I putting the speed down really low? It's because to, first of all, remove the continuous up and down of exposure. But we have likely a big range that moves slowly inside of this range. And the only one that we adapt faster is the actual adaptation to light, like it happens in real life. Like if we look on a dark environment, inside of the dark environment, and then we rotate instantly our head and we look to an highlight, you will see that for a fraction of a moment, that information of light outside of your window will be like blown out and then instantly almost adapted. But the rest of the environment remains the same. That's because we have a bigger range. It's like we have a big ass HDR monitor on our eyes that has a really, really enormous range. So that's why like we only adapt the light, not the actual shadow. But here we are trying to replicate that. Of course, we are not 1000% perfect into it, but still, here you can see that we have stability whenever we move around. And whenever we will be for a long time, not only passing through a dark area, we will start to get like slowly some more light in our screen. Again, this is not the perfect solution, but that's a way on how it could be approached. So in the future, hopefully, we will have a local exposure system that will give us the possibility to gather those info without having to mess too much with the exposure, right? So that we can only have more shadow information and only have more highlight information. So in fact, right now I have already set the local exposure to the limits of the system that are likely set by Unreal, so that we cannot, like if we start to go lower than this value, and I go here inside and we start to see it, if I go lower than this value, we can see that we gather more info, but then if we go to the daytime and we remove these, we see that we have flatter lighting compared to the one before, right? So it should be more dynamic, but right now it's a little bit more limited. But yeah, that's a way on how we can accomplish the volumetric clouds iteration with the directional light in order to have the cloudy weather condition. And I think it works. I mean, we saw with the dynamic characters that is quite well integrated to the scene with the shadowing, indirect shadowing, and so on.
Yeah, no, it looks quite good. I think the only limitation we can have is if we have half and half, like not quite super thick clouds, where that can still pass through some sun. The only unrealistic thing that we will get is that we still have um, perfectly sharp shadows.
Yeah.
But
Yeah,
that's yeah.
unfortunately, they don't work as a full diffuser. So the shadow, yeah, here also you can see that on the water, the shadow is sharp
Mhm.
because now it's not taking the occlusion. That's why you see it right now. But yeah, as Gian Pietro have said, take that in mind. So it's not fully working.
Yeah.
Uh,
I mean, you
but
can
still,
technically blur the virtual shadow map, but I wouldn't advise to go too crazy with that. Otherwise, you
a
spend one
lot of
FPS, yes, for every iteration of that.
yeah.
Yeah. So let's talk about
Um,
the night then. Yeah, that thing exactly looks good, but
you can see also the
uh,
noise. I think
yeah.
from the recording it will be visible, so that we have a lot of noise to the scene.
Hmm.
But yeah,
Yeah.
nighttime.
Nighttime.
So yeah, nighttime is again we have the photography as a reference, the photography word, where they have calibrated on which one are likely the parameter in order to have the right nighttime. And the lux that are calculated from the moonlight are what? One lux. It's what has been said it is the right amount to have for a nighttime. And now you can see that everything is really dark, of course, because if you remember before, we set our range. And EV1, by the way, is not a number that I just made up, but is likely the EV that always in photography has been said to be the one to be used for moonlight calibration. And now, because our speed down is quite low, you can see that it's taking time to arrive to the right amount of exposure. So now I will speed it up. Uh, and just to reconnect a little bit into that, again, I don't want to dig too much into it, but just to reconnect a little bit. In a ideal scenario, we should have the exposure following how much it takes for your game to adapt from to go from the sunrise to the nighttime. Okay, so whenever we go from day to night, we know how much time it will take,
Yeah,
and based
starting
on
from the
that,
assumption that you have dynamic weather in your game. Because if you have static and it's nighttime, you don't need that. But
yeah, exactly. So only in dynamic fields, yeah, correct. Otherwise, if you want to do only a nighttime, you know that is EV1, and you lock it as it is right here, and there you have it. You have the nighttime. And then I think one question can come up
but
saying,
arrows, I can't see in the shadows.
it's super dark. How in the
Yes.
hell can I play my game?
Well, it's night. You're not supposed to
Yeah,
see it.
exactly. So you are playing in the night. So if you want more, as I was doing here, you place a light. And then that light will give you the actual amount of light that you will need to visualize the scene. But yeah, apart from the jokes, it's likely we have to be mindful whenever we choose a time of day in our games. And it's also really connected to the design of the gameplay, to be honest, because whenever we have really dark areas like this one, all right, we have a really dark area, we don't see anything almost. One choice of design would be okay, yeah, we are we stick with that, but what we are going to do is to give to the player the possibility to use a torch, and a torch, a really good one, has 1000 lux. Okay, and you can see that is a big ass light in a condition like this one because of the exposure and everything that we spoke about. And you can see that then your character will instantly have more visibility to the environment. All right.
Mhm.
So it's really restricted to the game. Because another thing that everyone does, everyone, is to basically go into the skylight here and say, yeah, the shadows are too dark. Let me do this. No, yeah, it's still too dark. Okay, yeah, now I start to see information. That's the night that I have in real life. Nope, that's not it. That's not what happens in real life. And if you do something like that, okay, you have to be mindful that changing a skylight means that you are increasing the specular and diffuse of your lighting, right? So changing the specular and diffuse means that you are making it like 20 times in this case higher than what it should be based on what you are capturing. So it could be again also this one a stylized choice that you can make. But if you do it, you are not making a nighttime. You are making an ish nighttime. You are
You're
giving the
making
feeling of a yeah,
daytime, but blue and darker.
yeah, exactly. With a lower intensity of light. So you have your temperature, yeah, it's cool. Or even people go here and say, oh yeah, much more blue, more blue. And they go like that. They say, yeah, this is the preferred nighttime, and then they go also with the volumetric at 1000, so that it will look super cool. And they say, yeah, that's artistic lighting. But whenever you will go around in your scene, you are starting to see that, yeah, but like my lights are overpowering too much right now. Why in the hell are they overpowering a lot the scene? It's because we have overpowered everything else that is surrounding them. Okay, so it's always a game of balancing between those information. So if we want to have a nighttime, we are going to get night. Okay, and night means really low visibility, and the human eye is not capable to catch the full light of a nighttime. That's why like we don't see like really clearly whenever we are in nighttime. But again, the science of it will be more spoken in the future videos. But in general, that's where we have to balance what we want to get from our scenes. So, do we want to have a nighttime? Okay, so then it means that we have to stage the lighting of the area in order to work in the night. And working in the night means that we have low visibility and we will need more lights in order to give visibility to the player. Okay, like it happens in real life. Otherwise, we will not have street lights in real life if in the nighttime we will be able to see everything clearly. So that's why like nighttime is supposed to be a time of day where we don't see a shit, nothing. So and it's correct like that, and it should be always like that.
Yeah.
Okay.
You just see if you have the full moon, clear sky, and you have been in the dark for at least like 40 minutes, and then you see what is directly hit by the moon. Otherwise, good luck.
Yeah, exactly. So the visibility will be really, really poor. So yeah, that's really important to take in mind whenever we approach those fields of deciding, like designing more than designing the lighting of the game,
Yeah.
because lighting. I will open this little parenthesis that we mentioned the position of a level lighting artist that is designing the lighting based on the needs of the gameplay of the game, right? So whenever we decide to say, okay, so now we want nighttime, cool, or we want cloudy, cool, all right. So how do we design the lighting of the game in order to work for the gameplay? That's really important to say and to think about whenever you encounter those information. But at the same time, the fix shouldn't be, okay, yeah, let me rise this, let me rise that, let me up this, let me up that. No, the information should be, okay, so we have night. Night means poor visibility. How can we increase the visibility? How do we do it in real life? Which one is the way that we know as human beings that is likely the best way to have more visibility in a nighttime. And in our case, is using artificial lights.
Yeah.
It's not like rising the skylight of the world, but is using artificial lights, and that's
Yeah.
what we have to rely with.
You can't decide on having a night just because you want a night, but not going to deal with the gameplay consequences of that.
Yeah.
Like if you want a night, you have to choose the night because it fits what you want to do. Like night comes with all the scary things, the fact that you can't see much, has a different feeling from the day. If you want a day but darker, but like same amount of playable space and whatever, like you're just making a decision like for random decision, like why are you even putting in the game, going to the trouble of putting in the game like dynamic weather if you want that each weather condition is playable in the same way.
And I think some people takes as a reference the movie production that are like modifying the shit out of a frame with composition, with addition of lights in composition, or with grading and stuff like that. So those ones are really specific cases, and they work for the frame. In our case, we don't work on a frame. We work on a synthetic world where we have to, in real time, interact with it. So are two completely different approaches, right? So that's why like we have to be really mindful of understanding where we are working, okay, in this case for a video game, and why we are working a certain way than another. Really be really, really mindful of that, because then it will switch completely the way you approach information like this one.
Yep.
Yeah. And then I would say we can speak about the last topic about the emissives.
Yep, emissive. So there has been this guy, which is also a friend of mine from real life, that is also working for as a lighting artist in his company, and he posted under the dedicated text channel for the Q&A about our previous video that he found a way to have a constant emissive output regardless of the exposure of the scene. That means that if you have an emissive material that is a certain shade of red, by doing this operation, by dividing it by the eye adaptation value in the shader, the emissive value, and then attaching it to the pin, to the emissive color pin, you will have that exact shade of red, regardless of it's night, it's day, it's under the sun, in the shadow, whatever. That's a good thing if you need that kind of output, because most of the time, like for example, especially for VFX, many times they want the result to look the same regardless of the lighting condition around it. Let's think about usually the most classic example of the time is the fire. I want the flame of the fire. I'm doing it with a certain shape, with a certain volume, etc. I want it to look exactly the same and always be visible in every lighting condition. But that is good for controlling the output of effects or whatever emissive thing you have. But on the flip side, you're not following any PBL rule there, because you're changing as the exposure changes the intensity of the emissive at the end of the day.
I mean, it's not likely strict rule like someone will cut your hands if you do it. It's a way to adapt a system that has a good base with something that we need specifically.
Mm-hmm.
Like in that case, like you said, if you need a fire that is a gameplay asset that needs to be interacted with, then probably you will need always the visibility. But in my opinion, even in those cases, you can still make sure that you stage everything in order to make it work, even if it's not fully visible for the player. It's likely the same concept as you have some doors and you have to decide on which door you have to go. The easiest thing is like saying, okay, so I have a door that is green, a door that is red. So the red one is I don't have to go there. In the green one, yes, I have to go there. That's the easiest way that you can use in order to say go here, go here. And it's the same thing if you keep an emissive always there. You say, okay, that emissive is always on, so then I have to go there and I can see it from every distance, from every parts and everything. So that's the easy approach to something like that. But we can use other things. We can use level design, we can use textures, we can use assets, we can use composition, we can use lights, and we can use emissives. So we can use so many ways in order to tell the player do something. But again, that's merely like a decision making of someone designing a game, right?
Hmm.
So I think the people can go to the Discord to see the node and how it works, because the guy has posted every information about it. Uh, in our case here, we are going to take a look on how to set up a basic emissive and why it's a little bit different from the normal one if we are in a daytime compared to a nighttime.
Hmm.
So I'm gonna take, I'm gonna create a material really quickly just to attach an emissive to it. So we are going to create this emissive color here. Okay, and I'm gonna save it. Super quick, just to give the perception of what it means. I mean, I can multiply, we can do it later. So now I will create an instance and I will place an object. Have I done everything correctly on the shaders? Have I failed something?
Eh, I don't know. I would have put the node like one square on the left, but
Yeah, so I will try to be better in the future on shading. So we have an emissive right here. And if we place it in the scene and we give it a number of 1, that's the exposure that we are going to get with the EV1 setup, right? So because now we are in the nighttime. So if I increase the intensity of it at 10, we can start to see that we have much more information spreading out from the surface. So one thing is worth to mention. By default in Unreal, I would say there isn't anything that gives you the right emissive intensity based on the surface scale, right? So there isn't a node that actually does it automatically. There is a possibility probably to calculate that. I think Gianpietro can speak more about it more than me. But yeah, in our case now we are just seeing the concept of using it with the physical base values. So the problem is with the physical base values that now we have, say, 100, okay? And in the nighttime, we are really blown out, okay? And then we go again to our directional light, we put it to 120,000 lux, as we know that is the daytime uh, intensity. And now we have locked the exposure to the nighttime. We put it back to 11. And now what we are going to do is to take our sun and start to rotate it, because I want to show you one thing on why it's really, really difficult to balance those information. So as you can see right now, our scene, our sphere is still dynamic. Sorry, it's still emissive, but we don't see the actual light coming out from it, right? So the immediate thing that people will do is like, oh yeah, so let's increase it a little bit more. Let's have more light. Okay, so now we start to see. And if we rotate here, wrong angle, I think. Okay, so now we can see that we have much more visibility of that light, even in the daytime. That actually is not incorrect. That's how you will see like a bulb, right? So your bulb will still be slightly visible, like you see here. Like you can compare this visibility in terms of emissive compared to this one, right? So
hmm.
it's much, much higher in the daytime. But you can say, yeah, but now in the nighttime it's too powerful. Yeah, I mean, we have to stick with it. that's another concept that I want you to give a little bit so far. It's likely if we have an intensity, and again, right now we cannot say if it's perfectly matching, for example, a source of light or a fire light. But if we have that intensity, we know that that one is, let's say that it is the correct intensity of our light, all right, of our emissive surface. If in the nighttime, per se, like let's say this one is not fully nighttime, but you get the concept. If in the nighttime we get it to be like too bright, then it means that that light is really powerful. Okay. So if we have it lower, like in here, okay, so we have it much lower than what we had, 10 times lower. Okay. And that's how you see it in the daytime. Then in the nighttime ish, you can see that the intensity is not as bright as before. And if we actually have the nighttime, we can see that it's even more visible, the amount of light that is actually spreading out. So that's a balance again, right? That we have to always take into account if we work with emissives. And this thing is also like we can propagate this concept also for, I don't know, explosion with the FX. So if we have a VFX that has an emissive like an explosion, we know that like fortunately we didn't see explosion in real life at nighttime, but if you see a video of an explosion in the nighttime, it just blows up, right? It's not like perfectly balanced that we see all the gradients perfectly. It's blowing out because it's super strong, the intensity. And that's why you also see it in the daytime. In the daytime, you see an explosion, right? But it's not blowing out because, of course, the sunlight is taking over. And you can see also this asset. You see that it's not fully lit by the emissive, but it's instead being took over by the actual sun. And that's again something that we have to take in mind whenever we work with emissive. So we don't have to put 1 million as a value, okay? But we have to be mindful of which one we use, and then it will basically propagate on which one it will be whenever we have the need of seeing it, like in the nighttime.
Yeah.
Another way that we can do is putting a multiplier before the actual value of light that we put. So if we multiply it, but this is again a really sketchy thing that I'm doing at the moment. So it's not a correct workflow or physical based workflow because the physical based part is our lighting of the scene. And then what we input inside of it should take in mind that we are in that field of the physical based. So that's why it works working this way. So if I put a 100 as a multiplier, it will mean that my materials will have a multiplier of 100 that, let's say, is the correct value of balancing for an emissive. And now here, if I input 1, I have 100 initially. And if I input 10, I have 1000 as before, and so on. So you see, I don't have to go crazy with the values. The perfect thing will be to make sure that the light that you input in the scene, okay, is likely matching with the exposure of the emissive that you have, the emissive value that you have. So they should always match, right? So that in this way you can have likely a much more correct value and information in your scene. But I would say again, it is quite complex as a topic. So I would say it's better to eventually speak about it more in the future.
Hey, I'm from the future and I'm here to add a little note because to expand on what we just said about the fact that we don't know exactly what's the value to give to an emissive surface in order to make it glow in a physically accurate way, depending on the amount of lumens it should be emitting. So, as you can see from this sneak peek, I was working on my next video, which is about physically based self-shading, which is a little bit an oxymoron if you think about it, but once you see the video, it will make sense, and it will likely come out after this one that you're watching now. So let's see. So I was experimenting and thinking about the concept that we spoke about in this video and in the previous one. And I actually got an idea about how we could kinda know the emissive value to assign to a surface in order to make it emit a certain amount of light. So here I was doing this experiment, and just by looking at that like this, it doesn't make a lot of sense. So let's open the shader. And what you can see here. So I am printing on this half, this is the mask. On this half, I'm printing this value, which, as we just said, is a value of 1, white, made independent from the camera exposure. So regardless of the camera exposure, this will show on the surface pure white, like you see now. And on this other side, I have my experiment. So now you can see the whole sphere to be pure white, uniform. And that's why I have hard-coded an exposure value of 14. So now, if I do 10, let's say, you can see that the left half is still the same white as before, while the right half is overexposed, is glowing. And that's why here, by doing this, I'm telling the shader that I want a value of, let's say white, brightness, emissive brightness, that is correctly exposed only at EV14. So now it's overblowing the scene. Which means that now if I set 10 here, I go back to my previous situation. Sphere is uniform, I get exactly the white I wanted, properly exposed. So now let's go even more extreme, and I go to 6, let's say. Same situation as before. This keeps being properly exposed because it's made independent by this operation from the exposure of the scene. This is now overpowering. So I go to 6, and you can see that it matches again. Now, if I go the other way around, and I go back to 14, now you can see that the right half is too dark. Why? Because it's emitting light for an exposure of 6, which is lower. So I can't really see it. It's like shadow at this point. So now if I go up 8, 10, 12, 14, it matches again. So what does it mean? It means that we still don't know exactly, this is still not returning the emissive value that a surface should have to emit, let's say, 1000 lumens. It's not doing that. It's returning the value that your camera should expose to in order to not seeing like as an emitter, but just to read the color it is made of, let's say. So to give you an example on how you could use this to properly to create a physically based accurate light. Let's say you have a light bulb in your house, like an actual light bulb, and you know that emits 1000 lumens. Okay. Now I can take my camera, go there, look directly at the light bulb when it's turned on, and find the value, the EV value that exposed exactly the light bulb, not the surround the light emitted by the light bulb, but the light bulb itself. It means that I will see the light bulb like a of its color, like not glowing, but of its color, that I can maybe also read the brand that is printed on the light bulb itself clearly. And now I know how many EVs I need to properly expose that light bulb when it's turned on, the surface of the light bulb. Now what I can do? Okay, I know that value, so I know that if in engine I model exactly that light bulb of that exact size with that exact surface, I know that if I do this in my shader and I set the same EV value, let's say 16, I set 16 here, which will be an extremely powerful light bulb. I know that if I render my scene with the path tracer, for example, that surface will be emitting exactly the 1000 lumens I was looking for. If you use lumen instead, it won't be that accurate, of course, but I mean, it will still emit some GI that will be kinda good. But what you can do is to exclude that light bulb from lumen, so lumen doesn't see it, you just see the glowing, and maybe you couple to that light bulb an actual light in engine that emits those 1000 lumens. And in that way you have a physically accurate result, because the light going to the scene is exactly 1000 lumen, and the light bulb itself, it's glowing at an intensity that is physically accurate for that specific light. So yeah, that is something like it's not really knowing what's the correct emissive value for the surface, starting from the amount of lux that I want it to emit, but is like a step towards that. So yeah, not closed. Let's go back to the video. And that's it mostly. So if you have any more questions about what we discussed, or if you saw this video first because you weren't aware of my channel and now you go back and watch the previous video and you have more questions, be sure to join my Discord server, in which we have a dedicated text channel for this series of videos dedicated to lighting. You can also skim through the questions that other people made and see what was answered there. This time we won't do another Q&A because otherwise we keep going to infinity, but EROS will be there to answer your questions. Remember to subscribe to the channel first of all, because so you don't miss any new release, and keep in mind that the next release on this series will be we will talk about artistic expression through lighting, how to do storytelling. We will work a bit more like in a level. We will be working closely to level design, let's say, to guide the player through illumination, to add some storytelling, give color to a scene. All these things that lie more into the artistic choices, let's say. It will be, I mean, it still will be technical, because at the end of the day it's a technical topic, but it will be more like the artistic part of it. So thank you for being here, and we hope to be able to record the next episode as soon as possible. And yeah, give us all the feedbacks you want. Thanks, EROS, for being here. And yeah, we will see you either on the Discord server or in the next video.